Hello everybody and welcome to exercise 4 on page 34 here. Okay, and this is a nice type of an exercise to really see if you see the connection between the function and its various derivatives, what kind of information the derivatives gives you about the shape of a curve. Okay, so let's read this question together. So in the space to the right, sketch the graph of one function f of x that has all of the following properties. Okay, so just to emphasize what they're asking us to do here, we're trying to draw the graph of just a single function, one function, and it's supposed to have all of the properties that we're seeing down here at once. Okay, so I like to use kind of a systematic approach. Just work my way down this list gradually and see if we can draw this function in pieces, keeping in mind that we may need to make some adjustments. So have your eraser handy as we do this. We're gonna do this kind of in stages and discover that we have to sort of erase parts of our graph and make corrections as we go. All right, so let's start with the first condition. They tell us that f of 0 equals 0. What is that telling us graphically? Well, it's really just telling us that there's a point on this curve where x is 0 and y is 0. Okay, so we know that our curve, whatever it looks like, goes through the origin. Okay, and then we move on to part B. Okay, and part B is telling us that f prime of x is greater than 0 on two intervals and that it's less than 0 on one interval. So what we have to ask ourselves is, what does it mean graphically to say, for example, that the first derivative of f is positive? Okay, well, that's another way of saying that our function is increasing. Okay, and then similarly, where the second derivative is less than 0, that's telling us that our function is decreasing. All right, so if we look at the first interval they're giving us, remember this notation means just the interval of x values all the way from negative infinity to x equals negative 2, just to help us picture that. I'm going to insert a dotted line. So everywhere to the left of that dotted line, we want our function to be increasing. Okay, so I'm just going to draw anything that's increasing. So maybe it looks like that. Okay, which takes care of this interval, and we're ready to move on to the next interval from 2 to infinity. Okay, that would be to the right of this dotted line that I'm drawing. Okay, actually, it might be easier to wait on that interval and to jump down here first, negative 2 to 2. I like doing that interval next because x values between negative 2, they occur in this range of our graph. It's kind of natural maybe to do that stretch of the graph first. Okay, so we can see from the condition that we're given, the derivative is negative between x equals negative 2 and 2. So whatever we draw has to be decreasing. Okay, so I'm going to start up here. We know that we're going to go through this point at the origin, and I'm just going to draw a graph that's decreasing. Okay, maybe something like that. Okay, which takes care of that interval. And now we're ready to move on to the last one. So from x equals 2 to x equals infinity, now we're talking about the part of the graph that's over here to the right. And we can see from the condition that f is increasing. All right, so we want to draw a function that's going up. Okay, so maybe something like that. Okay, so what you see in front of you over here to the right, let's clear a little clutter away, is our first attempt at the graph of f. Okay, and it pretty much fits everything in conditions A and B. Okay, we've got it increasing and decreasing in the right places, and it's going through this point at the origin. Okay, but what about condition C? Okay, well, let's just do a little clearing away here, and we'll just focus on C now. Okay, so C is giving us information about the second derivative of f. So we need to ask ourselves, if somebody tells you that the second derivative of a function is positive, what is that saying graphically? Well, it's saying that our function is concave up, okay, that it has sort of a bowl upward shape. And if the second derivative is negative, it's telling us that we're concave down. All right, so what we're going to do then is to look at these intervals one at a time, starting with the interval from negative infinity to negative 3. Okay, we want our function to be concave up on that interval, and negative infinity to -3 would be about from here to here on our graph. Okay, so what do you think? Looking at that stretch of the graph, does that have a concave up shape? It doesn't, because I drew a straight line. So the question then is, how do we change the shape so that our function is increasing, but it has a concave up shape? We just need to bend the curve a little bit. All right, so I'm going to erase that part of the graph and just draw it so that it sort of has an upward bowl type of a shape. Okay, so maybe something like that. Okay, and then let's see, we are sitting at x equals -3, so maybe the next good interval to look at would be from -3 to 0. And you can see from the condition that we need to be concave down from there to there. So -3 to 0, that would be from here to here. So we're sort of looking at this part of our graph. We want to redraw that so that it has a concave down shape. So we want it to look like a downward ball. All right, so let's erase this. We're going to try to make it go through that same point that we already drew up here, but we just want to draw it in such a way that it kind of has a downward ball shape to it. Okay, so maybe something like that. All right, so let's see, we're done with those first two intervals, and then next thing we come to is the interval of x values from 0 to 3, and we're concave up again on that interval. And let's see, 0 to 3 would be from here to here. So we're talking about this part of our graph. We want to just redraw it so that it has the shape of an upward facing ball. All right, so let's erase and redraw here. I'm going to try to keep that point, and then let's just draw it so that it looks like a right side up ball. Oh, whoops. I went a little bit too far. We want to stop at 3. Okay, I didn't do that quite right. Let me try that again. Okay, this iPad screen is kind of slippery, so you notice that it's a little bit tough for me to draw this right, but maybe something like that. Okay, and then finally, we come to the very last interval from 3 to infinity, and on that interval, we want f double prime to be less than 0, which means we want it to be concave down. Okay, so we're just going to redraw this last part of our graph so that it has a kind of a downward facing ball shape to it. Okay, so maybe something like that. All right, and so I think we've drawn a graph that has all the properties that we want, and I want to emphasize here that that's not the only graph that you could draw. Okay, we're basically just being asked to draw it in such a way so that increasing, decreasing, concave up, and concave down agree with the conditions that we have here, but there's a little bit of flexibility. When you drew this, your points might be a little bit higher or lower than mine. All of that's okay as long as we meet these conditions that we have to the left here.